And we're live. Hello, everyone from Athens and from Helsinki for another online meetup. We're here today with Antti Rössi. Antti was a speaker in the last Laracon Madrid, and he gave a very nice presentation about security. And we decided to invite him today to speak remotely. So before we start, we would like to thank our sponsors. We have Stone Soup, who is providing the room here, so we can meet. Stone Soup is a very cool co-working space, and we highly recommend it. And also the other sponsor is LearnWords, and you can find more on the comments. So LearnWords is a video platform that makes it easy in order to publish your own videos and make some money or teach other people how to do stuff. So thank you very much, LearnWords, for your sponsorship. And today we have Antti, who will speak about security. Antti, hello.
Hey, great to be here. So glad you invited me to talk here.
Yes, amazing.
Should I talk? Start?
Give me 1 sec. I will try to find out how to make this full screen.
Okay.
That's a good challenge. No. What about this? Okay, I think we're good.
Okay.
So go ahead.
Excellent. Before we begin, I'm gonna have to go through certain topics quite fast. So if anything happens to the connection or sound quality or whatnot, just please stop me immediately so you won't miss any part of the talk. It's gonna be important.
Yeah.
Excellent. So great to be here. Like I said already, it's actually rather nice to talk from my own office. Don't have to fly anywhere. I like this format quite a bit. So today we're going to talk about how your Laravel application can get hacked, and as a developer, what you can do to prevent that from happening. Majority of the talk is going to be same stuff that I was talking in Madrid. However, there are a couple of parts completely new. So hopefully, even if people have seen my previous talk, there's going to be something new for you to learn from here as well. Quickly about me before we continue. So I'm based in Helsinki, Finland. My name is Antti Rössi, and I'm the CTO and co-founder of a company called Jobilla. So during daytime, I'm basically building a digital recruiting tool. And probably the reason why I'm usually talking, well, in all sorts of meetups, I do a lot of DevOps stuff and InfoSec stuff and a lot of development stuff. I build stuff with PHP, Laravel, Vue.js, Python, C++, all sorts of programming languages. And usually probably why I'm talking in developer conferences about security is because during the daytime, I'm a developer myself as well. So the perspective where I'm looking from towards security is a very, very developer-friendly way of looking at things. However, during nighttime, I'm usually hacking software in order to make it more secure. So that includes capture the flag challenges, penetration testing, bug bounties, and basically those are the three main categories, but anything, all kinds of events and trainings and sessions that are related to security somehow. So you could say that I'm a big security enthusiast. You can find me on Twitter. If you want to learn more, I tweet sometimes, not very frequently, but I like to share useful resources for developers who might be also interested in security. Before we go into the actual exercises and examples, please understand this. All the material and examples in this talk are for educational use only. Hacking as a rule of thumb is illegal, so don't ever hack anyone else's machines but your own, or anyone else's services, servers, anything. So hacking will get you in jail, or if not in jail, at least in trouble, so don't do that. The purpose of this talk, the intent is to help professional software developers to write more secure software. That's the point of this talk. This talk is not intended to teach you how to hack into somebody else's systems. That's not what like. Well, I guess you could use these techniques for that, but don't. That's not what I'm endorsing here. So just want to be clear on that. However, if you get very excited about this talk and these upcoming exercises, there's a place in the web. Well, this is just one of the places, one of the best that I know personally. But you can head over to hackthebox.eu and you can actually hack legally for free there. So you can learn hacking. You can there's plenty of vulnerable PHP services up there that you can actually hack for free and practice your security skills if you want to. That's going to be the right and the legal way to practice and get better at this. So what's coming? What's coming next? We're basically going to go through 5 common exploits and attacks that you're going to face in the wild as a Laravel developer. Before we get into the actual example number 1 first, however, people ask me this a lot, and clients ask me this a lot. Everyone who hears that I'm working with PHP or Laravel in general wants to know about security of the Laravel framework itself. So is Laravel secure? No framework or technology can ever guarantee that your application is impenetrable. And I want to be fully clear on this. So the framework, whether it's Symfony or Laravel or you're using some other technology completely, can't guarantee, it can make you unsafe if you're using vulnerable technologies, obviously, but it can't guarantee that you're safe. Laravel gives you an excellent modern base to build secure applications with. However, your application is only as secure as its weakest link. So you have to take into account all the dependencies and the whole supply chain of everything, every single component and dependency and library and package that you're using. A vulnerability in one of those spots is going to make your whole application vulnerable. That's why security is a rather tedious topic for developers and everyone to talk about and to work with, because it's quite unforgiving. All of the following attacks are exploiting vulnerabilities caused by engineering flaw by either the developers or the admins of the example applications, which, well, basically is me, because it's an intentionally vulnerable application that I built that we're going to exploit next. None of the attacks or exploits are anyhow caused by Laravel or made possible by Laravel. So I want to be fully transparent and like overly clear on that. So we're not hacking Laravel app like the Laravel framework today. We're going to be hacking an application that's built with Laravel. That's a very, very important distinction to make. We're going to have a look at cross-site scripting attack, short XSS attack first. So in cross-site scripting attack, the attacker executes malicious script in the victim's browser. With XSS attacks, targets are usually authentication tokens or some other sensitive data that lives in the browser of the victim. So it can be anything. It can be credit card information, but anything that you can achieve from the browser's JavaScript context, basically. Now, here's one way that an XSS vulnerability might slip into your application. So if you're echoing unescaped content in your Blade templates, for example, you're potentially echoing script. And if that script is not authored by you, if it's a user-generated script, it might be malicious. That's one sort of a way where a cross-site scripting attack might happen in your Laravel application. So if you're using unescaped echo, be super careful with what you're actually echoing into your DOM. Let's actually have a look how such an exploit would work in real life. So I have an example application in here. And actually, by the way, if you get interested, you can actually find the source code for this exercise in GitHub. And you can download this. And you can actually do these exact same exercises and examples yourself at home if you want to learn more. So obviously, because I work with jobs and hiring, it's a job-related example application. So let's find our target. We're going to go to companies. And hacking a Laravel Inc. is going to be our target today. So very common place to perform access attacks from is going to be some sort of messaging. You're sending messages or uploading files or something. We're going to use a contact form in this case. So we're going to inject some malicious script into this contact form and then trigger it and see what happens. So let's say sender is going to be hackerman at example.com. Title is going to be hey, what's up? And into the message part of the contact form, we're going to embed our script. Now, I have the script ready. It's part of the source code. And let me zoom in a little bit. So we don't actually have time to go through every single line of this exploit code. You can look at this on your own time if you wish. However, here's the core of the source code. So this part of this snippet of JavaScript is basically going to perform some hacking magic, let's call it that for now, for lack of a better word. But the ethos is on the line 47. So we're making a fetch request, and localhost is the malicious server, the hacker's address in this case, since we're running in a Docker container. And we're going to put whatever details we can steal into the URI params of this request. And now how this attack works is we're just going to take the code, we're going to paste it in, and obviously we have to wrap it in script tags since we want this to execute as part of the DOM. So script, there we go, then we're going to send it. Voila. And then we're going to trigger it as a victim and see what happens. However, before that, if we know that there's an HTTP request coming in, we obviously need to catch this somehow. So we're just going to use a very simple PHP web server. So we're going to use PHP serve localhost 8888. So we have a web server running, which should be able to catch the request. Now I have the credentials for a basic user stored in here. So we're going to act as a user now, who is basically coming into this fabulous example application and going to read that message and see what happens. Let's actually open DevTools so we can see maybe something interesting in the console. So we're going to press login. We're an unsuspecting visitor, and we can actually see some suspicious errors in the console right off the bat. But you can see the message that we sent is embedded in here. And if we actually go inspect it, there's literally nothing in the message. Well, obviously, since that was script that just executed, and we can see there's actually a 404 coming back from an HTTP request. And if we go to terminal, we can see the request was caught in our machine, the hacker's machine, and we have the authentication cookie in here. Now, obviously, what we're going to do, we're going to copy this. We're going to use Alfred to decode it to make sure we get the, what do you call these quotes, right around the token. Copy the token that we just stole. Oops, not here. Let's actually open a incognito window, and we're going to continue from here. So, well, it's going to be as simple as this. We got the value of the cookie now. We're just going to go to the front page. There's a standard PHP session cookie. We replace the value with the one we just stole. Refresh the page. And we have a user account. That's basically how easy exploiting a cross-site scripting vulnerability can be, depending on the situation. But that's pretty bad. That's very bad. And we're actually going to need the user account to proceed further in this presentation. So let's stay logged in. Next, we're going to have a look at SQL injection. There's also no SQL injection, by the way. So no SQL does not mean no problems in this context, unfortunately. All the database engines are vulnerable to injection style attacks, if not configured and operated properly. In SQL injection, the attacker injects malicious SQL queries into an HTTP request, for example. If and when successful, SQL injection attacks can lead to the full disclosure of your database content, which is pretty bad. Like if you thought cross-site scripting attacks are bad, wait until you see what SQL injection looks like. You've probably heard about the dangers of using raw queries in Laravel and Eloquent in general, and this is actually the very same example that we're going to exploit next. So there's an unsanitized order parameter coming into the query, and we're going to be able to inject like SQL query parts into this variable basically, and that's what's going to open up the injection vulnerability in this particular use case. However, this is just a very basic example code-wise. Certain edge cases can be very, very hard to spot in terms of SQL injection, especially if and when you have highly nested object-oriented code. You have repositories, all sorts of dynamic query building and dynamic includes and sorts and filters and whatnot. It can be super, super hard to spot edge cases that might expose you to SQL injection. However, it's fairly easy to test and extremely easy to exploit with proper tooling, especially if you have identified the vulnerability. There's like lots of automated SQL injection exploitation tools that basically do all the heavy lifting for you. And now from a developer perspective, that's bad news. Let's have a look at that next. So now we're into the system, and we can actually access a new part of the system called jobs in here, which is still under development. So you need a user to come here. Let's open DevTools. I'm going to actually zoom these tools a little bit. Go to the Network tab and refresh the page. Now we're going to see there's some sort of API call that's going out from this table component. And we can see here is the infamous sort parameter that's been passed into the API call. So we can have a look at it. Yep, it's returning JSON for us. Excellent. So we're going to take this URL and we're going to try out a tool called SQL Map. So SQL Map wants the URL that you are going to test with it. So we pass in the URL. Then we're going to say database management system is called MySQL, just to make it a little bit faster. And we're going to run it. Now, usually it takes actually a little while to execute. I've pre-cached these results for us before the presentation, so we don't have to wait for an hour or whatnot for this tool to run. But SQL Map tells us straight off the bat that there are vulnerabilities found in the sort param that we passed in. Boolean-based blind vulnerability and time-based blind vulnerability. And what that basically means, now when SQL Map found those vulnerabilities, it actually also knows how to exploit them. So let's try something. Let's say current DB. So let's see if we can get the current database that the application is running from there. And yes, we can. It says current database is called Laracon_Madrid. Okay. With that knowledge, let's say, okay, database is Laracon Madrid. What about the tables? There are 7 tables in the database Laracon Madrid. That's interesting. Messages, jobs, migrations. Let's look at users. Database Laracon Madrid table users, and let's say --dump. Okay. So looks like we are getting the content of the database table out, basically. And we can actually see something interesting here. There seems to be an administrator user, and we have a password hash in here that might be useful down the track. So basically, with SQL Map, we can get anything out of the application. We have the same privileges to the database that the Laravel application has. And we did not have to write a single line of code manually. We're just running comments from the CLI. So not too hard, not too hard. Okay, so we got the hash out. Now this is the part that was not included in the so-called original talk in Madrid. So we're going to perform a password attack next, since we got the admin hash. And in order to proceed, we're going to need an admin account to properly, step-by-step, get deeper into the application. And we're going to look at password cracking attacks specifically, like not password sniffing attacks or any of that. So there are a couple of different types of password attacks. We're specifically going to look at dictionary attacks here. So in a password dictionary attack, the attacker basically compares the acquired hashes against a set of known hashes to find a match, which from a developer's perspective sounds quite not so sophisticated, to be honest. It's and it's actually not. So, and there's basically no way to prevent password attacks completely. And obviously, the strength of the password and the password hashing algorithm used, they determine the feasibility factor for password cracking. You've probably also heard about brute forcing attacks. And brute forcing attacks are usually not very viable option, especially against Laravel if you're operating over HTTP, because Laravel automatically includes throttling middleware that just basically bans you for a minute or so if you send more than 60 requests per second to the service. However, if you have the hash, you can send million requests a second. You can do whatever you want with it as long as you have enough bandwidth and computing power on your machine. Now, however, if the password is very strong and the password hashing algorithm used is also computationally expensive, it's not going to be feasible to crack password. If it takes 150 years to crack a single password, it's theoretically doable, but it's technically not feasible. So that's basically one of the only ways to protect yourself from password attacks. Obviously, not giving out the hashes in the first place also helps a lot. So in no circumstances should anyone see those hashes. The hashes only get disclosed in a breach, like just happened if somebody exploits another vulnerability and gets into your database. So yeah, no one should ever see those hashes. So for the dictionary attack we're going to perform next, we're going to use sec lists, which I guess it's a short for security lists or something. So internet is obviously full of all sorts of password lists and security lists, what you can use for fuzzing and dictionary attacks and whatnot. One of the most known is called RockQ, which includes 23 million different passwords used, if I remember properly. And in sec lists, it's available in GitHub. There's a link here, and you can see from here. Oh, my cursor went missing. Okay. Well, anyways, you can see in the middle of the image we have dark web 2017 top 10,000 most used passwords, for example, which seems like a pretty good candidate for an example like this. And if you want to see what's in there, you can just download this list and go have a look. They're actually rather hilarious, and it's not well, I can show you in a little while. It's not very convincing to see what sort of passwords people are actually using, so that's rather disappointing. Round 3, fight. So let's take the hash that we just acquired. I'm going to copy that. By looking at the beginning of the hash, if you know about hashes, you can actually tell that it's a bcrypt hash. So it's using a so-called blowfish algorithm. The beginning of the hash reveals that. So we know we're going to be using a bcrypt algorithm to crack it as well. Let's echo the hash into a file first of all. We're going to put it in a temporary location. Let's call it hash.txt, for example. Now I'm going to have to go to a different location where I have my tool called John the Ripper installed on Mac. I'm usually doing penetration testing on a completely different machine, but we're going to have to run it from this location. So we're actually, let's see, I have the command in here. So we're going to run John, and we're going to give it a word list. And now word list is going to point to the list that I just mentioned. I can actually show you real quick what the word list looks like. So it's literally just a ridiculous list of passwords. And you can see there's rather intricate and creative strings of like sequences of numbers and all sorts of Skittles 1. Probably not something that you could guess straight off the bat, but when you have a list and behind the list there's a statistic that 100,000 people used this password last year, it's actually a very, very bad idea to use a password like this. Enigma Platinum Froggy. Password 10. Nice. So we're going to give that list to John. And oops, then obviously we're going to give it the hash, the location of the hash, and then we're going to tell it that the format of this hash is going to be bcrypt. And it's going to tell us that it's either a 32 or 64-bit blowfish hashing algorithm that we're using. Now, bcrypt is a relatively safe and good hash, so there's nothing wrong with using bcrypt. However, if the password, yes, well, it actually returned quite fast. The password seems to be blue sky, which is not very strong password, one might say. Let's actually take it and see if it works. So if we go up a bit, we can check what was the admin user's email address. Let's copy it from here. We can log out from the system. Log back in, blue sky. And we're in with an administrative account this time. So obviously, if the password was not found in this password list that we used for the dictionary, we would not have been able to crack it this way. So that's rather unfortunate. That's one of the reasons why people in InfoSec constantly talk about having strong passwords and password security policies that are super frustrating to users. But if you have those in place, nothing like this could ever happen. So it's probably worthwhile thinking, at least. Malicious file uploads, we're going to have a look at next. And there's also remote code execution, which is sort of a related exploit. So improperly validated file uploads can allow an attacker to upload and run malicious scripts on the target machine. Sounds scary. Around half of the tutorials that I found online when I was Googling for how to upload files with Laravel, they don't mention file type validation at all, which is quite bad. It's quite basic, but especially for beginner developers, definitely something that you want to enforce. And the reason why I want to do that is because malicious uploads very, very easily lead to remote code execution on the target machine, unfortunately. Let's have a look at that next. So we've got an administrative account, and there's a new link in the menu now called Documents, which we can, oh my God, what is this? No, you didn't see anything. Let me quickly go delete this. And we're back. So documents. Document section has a very simple uploader. Now, this uploader code is actually almost directly copied from one of those search results that come from the first page in Google when you Google for how to upload files with Laravel. So the validation is almost absent in this scenario. Let's quickly engineer a PHP backdoor script that we can use for this use case. So we're going to go to the same temporary location where we have the hash here. And we're going to open a new file called rce.php, which stands for remote code execution. Now, obviously, we need to tell that it's a PHP file. And actually, building a backdoor is as simple as this. So we're going to use a system call here. And we want to pass in a parameter through request. Let's call it PWN, for example. That's it. That's as simple PHP backdoor as you can basically have. So let's see, we have it in here. Let's just double check that it actually has what we intended. So system from request parameter PWN. Excellent. And I'm going to move that into downloads so I can access it a little bit easier. Let's choose the file. Submit document. There we go. Document has been uploaded. And now since it's a document uploader, we obviously have a view document link in here, which leads us to the file. Now, Apache out of the box does execute PHP files from the upload location, like we're seeing in here, which is super, super bad news for you. So you have to be cautious, and you have to explicitly, if you're using Apache, or well, in certain configurations with Nginx, it's going to be the same case. So please make sure that PHP scripts are never ever been executed from your uploads directory. And this is the reason why. So if we pass in the URL param, the PWN that we specified, we can actually execute comments on the server like this. So this is basically what the remote code execution is all about. So lsla, we see the content of the directory, cat etc password, we can see the users of the system. And now the worst of all, we can actually hijack the machine completely. So let's start a TCP listener on our local host. We're going to use a tool called netcat, short NC, for this. So we're going to be listening on all the interfaces and port 7331. And now, since we know we can execute commands on the target machine, we can also use netcat or, well, any other tool that supports TCP, PHP, Python, Perl, Bash. But we're going to be using netcat here. We can dial to Docker for Mac localhost, which is the localhost address when you're dialing in from the Docker container. And port was 7331, and we're going to pass in a bash shell. The command is hanging. So we got a shell access to the machine, basically. Now we're a user daemon. We're not an admin or root user yet, but anyways, you can see it's certainly not something you want to have that happens in production for your application. Anyone ever to be able to reach command line on the host machine, that's extremely bad news. And that's what's going to happen if you don't validate your inputs, file uploads properly. Okay, so we got the machine. Now there's still one final layer for us to exploit, and that's going to be our final boss, privilege escalation attack. Privilege escalation attack means that you're exploiting a bug, design flaw, or configuration flaw to access resources that your user account normally could not access. So you're reaching out to admin and you're doing something that only an admin should be able to do. Since we got CLI access to the server, the host machine, one way to escalate privileges is that you find something on the machine that's running as root, and you exploit that. You try to hijack the process that already has elevated privileges on the host machine. Very few things should ever run as root on the host machine. Laravel Artisan Scheduler is most certainly not one of these things. So Artisan Scheduler should never run a super user of the machine, regardless of the operating system and the platform. The reason why I included this specific example, because I personally used to run production systems for multiple years back in the day like this, simply because I didn't actually understand that there's any problem or any risk in running scheduler as root. That just accidentally happens for most of us. However, let me show you why that's an extremely bad idea. So we're going to have to do a couple of tricks, since, like you can see, it doesn't actually look like a proper terminal. We can't even switch users. We can't do half of the things that we could with a normal terminal. So we're going to be doing some magic comments in here. We're going to be using Python's pty, and we're going to wrap it over a bash shell. So now we have something that already looks like a terminal. However, we still can't actually do all the actions that we normally would. Like you see, I tried to switch a user here using a command su, switch user, and you don't actually see all the interactive inputs properly from the terminal because we're still running through netcat, we have to remember. Even though it looks like a terminal, it's not an actual TTY. So in order to be able to actually modify files on this server, like we can't just jump into Vim straight off the bat. We're going to have to do a couple of tricks. So we're going to background the session using Control-Z first. And let's check what are the zoom options in our terminal right now. So we're running at 33 rows and 128 columns, okay? STTY raw minus echo FG. So we're back. And everyone's thinking, what on earth is happening? I'm setting a couple of variables to make sure that our terminal is in sync with the terminal of the target machine that we're hacking right now so that we can actually use Vim in a second. So shell equals bash, term equals screen, STTY rows 33, columns 128. We should be able to run clear now. What is going on? Oh my God, should be this way. Shell equals bash, term equals screen. Let's try again. Clear. Yes. There we go. So we should even have auto completion now. Let's see. CD app. Yes. Console. Now here we see the console kernel, which is where the scheduler configuration lives. Let's jump in there with Vim. Okay. You've probably seen this file before if you've worked with Laravel. So this is where the scheduler configuration is operated from. Let's put it in the center. So if we know that scheduler is running as root, whatever we run from here is going to be executed as root as well. Let's see what we can do. So schedule exec. I didn't know about this before, but you can actually execute arbitrary shell commands in scheduler. And we want it to run every minute. And you can probably already guess what we're going to execute in here. Netcat, Docker for Mac local host. Let's say 1337 this time. And with E flag, we're going to pass in our good old friend bash shell. However, before we actually save this file, let's open a new window in terminal and open the actual netcat listener so that we're going to catch the TCP connection when it comes in. Save the file. Let's look at the date. 19 seconds. We're going to have to wait almost a minute for the scheduler to run because it runs every minute. So while we wait for it, we can enjoy this little GIF, which is one of my favorite GIFs. Look at this. The guy's hacking with the banana. Oh my God. Okay. 10 seconds to go. And the reason why scheduler runs every minute, even if you don't run your own commands every minute, is obviously since the scheduler default configuration is configured so that every minute is the fastest or is the shortest interval that you can run it in. So that's what you basically put in the Linux cron tab. So we are there. It has executed. Now when we switch terminal window, oh boy, we have shell here again. However, if we run who am I this time, we are root. And ID verifies that the user ID is 0, which means we're the first user and the most privileged user in this system. GID 0 groups 0. So whatever you can do in the system, we can do right now. Okay, so the machine got hacked. How do we protect ourselves? How do we not get hacked? That's going to be the focus of the next 5 minutes, 5 last minutes of this presentation. Tip number 1, don't ever trust user input of any format. Validate everything and sanitize everything. For file uploads, this is the crucial part that was missing from half of those examples online. So Laravel has very good file MIME type validation support. It's really good. I have not found a way to go around this yet. At least I've tried, spent multiple days trying to hack this. Not an easy thing to do. Use this for all the string content. There's a couple of excellent functions inbuilt in PHP that allows you to disarm strings so that if there's JavaScript in them, they're going to turn into text that won't execute. They're going to be destroyed basically. So please do that. Disarm all the input. And regardless of the templating engine you're using, or whether it's in PHP or some single page application framework like Vue or React, make sure that you only use unescaped versions when you absolutely need to, which is usually almost never. So the default variable mechanisms in templating engines usually protect you from cross-site scripting attacks. So please do use the basic version. Tip number 2, don't run outdated software in production. Now, the reason why I bring this up is because there's an Apache vulnerability that's a rather old one. So it's from 2012. And the reason why we were actually able to get the authentication cookie out from the browser is because the Docker container setup for this exercise is running an old version of Apache, and it's actually a very old version of Apache. So if you were running the latest version, sort of stupid, commonly known old vulnerabilities like this could not be exploited in your production machine. However, if you have some goodies in local storage, like a lot of the projects do, then even the latest version of Apache would not protect you from this attack. But it's still something to be wary of. Updating, security patching your software is super, super important. Tip number 3, do not run code that you don't understand in production. For example, copy-pasting code from online tutorials, like for demonstration purposes I did in this example. If you don't understand it, it doesn't qualify to run in production. It can contain whatever. If you don't know what it does, well, obviously, with basic logic, it can do things that you're not even aware it's going to do. So that's a really, really bad idea. Tip number 4, follow the principle of least privilege. So by default, don't give anyone access to anywhere, and then start granting privileges, the bare minimum privileges to processes and users, what they actually need. Anyone should never have more access than they absolutely need. That's also one way to make your application much, much more secure. Automate everything that's reasonably possible, because automation reduces the chance of human error and makes your environments and configurations much, much easier to audit. So provision servers automatically, run updates automatically, and well, you could also add in here do code reviews and all of that stuff. But automation means that, like, well, you don't accidentally open up a firewall rule if it's only configured automatically and changes are always code reviewed. That's basically the ethos here. Don't leave utilities that you don't actually need on a production machine either. So in this case, for example, why on earth was netcat enabled on the machine? Not having netcat would not have stopped us in this case, but it's once again, if you have quote unquote useful utilities on the machine that you're not using, somebody else might use them. So it's usually a good idea to remove them. And if you're root, you can install them when you need them and then remove them again. And last tip, enforce strong passwords and also use strong passwords everywhere. And you could even add in here, use multi-factor authentication everywhere, whenever possible. So even if somebody gets a password, they can't actually do anything with it. Now, this is going to be one of the most important takeaways from this talk. So security, please understand this. Security is not a one-time effort that you can just tick off your to-do list. Security is an infinite, ongoing process. And it requires all of us to pay attention to it every single day we write or run code. Every single day. And remember, you've learned some exploitation and hacking techniques. With great power comes great responsibility. Please use this knowledge wisely. Thank you. That's all I had to say for this. And please use the knowledge for making your applications and your users safer than before. Don't do any bad things with this knowledge.
Right. Okay, so can you hear me?
Yep, sure.
Yes. Thank you very much for the presentation. Many of us were shocked during the slides. It was amazing. So, how can we ask questions? If you have any questions, how can we reach you?
The easiest way probably is going to be via Twitter. That's where I can answer the questions publicly, even. Yeah. I'm also currently part of your Laravel Athens Slack group. So obviously you can just message me there. That's completely fine as well. I think I would rather prefer Twitter. So that's probably going to be my tool of choice.
Great. And do you have any reading material you would recommend? I mean, how can people get to know more about security and writing secure code?
I think the best way to enhance security seriously is to learn the basics of hacking. And that's why the term ethical hacking is used across the industry so widely. And the reason why I'm giving out these presentations in different conferences nowadays is because when I learned how to hack some years ago for the first time, I realized that every developer should know these things. So the best way to actually understand SQL injection is to learn to perform SQL injection. Now, there's an excellent video series. If you get interested in Hack the Box challenges that I mentioned earlier, I can post these links in the Slack or in Twitter, but there's excellent material available in YouTube where there are people going through these exercises and actually showing you, explaining and recording their screen while they do these exploits simultaneously. And you can then go online and do the exact same thing. Like you can find the service and you can practice your skills, and that's going to be the best way to get better.
That's amazing. Okay, Rössi, thank you very much. So thank you everybody from the online YouTube channel for watching, and we'll see you next time. Bye.
See you.
Bye.